Okay, so the thing about the statics, the torques, is you got to keep track of the sense of the rotation about whatever the pivot point is that you're using. If a torque is trying to rotate clockwise around a pivot point, you're actually going to set that to be negative, is the convention. If it's going counterclockwise about that pivot point, wherever it is, you're going to set that to be a positive torque. Counterclockwise is positive, clockwise is negative. Whenever you're doing one of these statics problems, nothing's actually rotating, so your angular momentum is 0. You're allowed to pick any point in the whole thing as your pivot point. Any point in the whole thing can be your pivot point. When stuff is actually rotating, there's two things you can do. You can either use the center of mass as the pivot point, or you can use any fixed point in the system as the pivot point. So you can evaluate angular momentum about any fixed point of the system, any point that's not moving, or you can do angular momentum about the center of mass. Of course, whatever you pick to be your pivot point or your axis of rotation when you're doing angular momentum has to be the same point that you are using when you're doing your torques, when you're doing R cross F for your torques. Okay? Yes. But with statics, because every point in the system is a fixed point, it means that any point you can use as the axis or the pivot point, whatever you want to call it.